Hello and welcome to MedEvidence Articles, where we encourage community research and education with weekly articles. I'm your host, Benton Loeyball, and this week we're talking about an immune-mediated disease, understanding celiac disease, and the latest research. My cousin is in town, which means I'm baking bread every 2 to 3 days to feed him and keep him happy. If we run out of bread, he runs around like a chicken with its head cut off. Actually, more like Chicken Little, yelling that the sky is falling. His dramatic reaction to bread reminds me of a serious health condition, celiac disease. Celiac disease is a chronic immune-mediated disease which primarily affects the gut. Immune-mediated diseases are those where the immune system of the body mistakenly attacks healthy tissues and causes damage. Celiac disease is unique among immune-mediated diseases in that we know the environmental stimulus, gluten. Gluten is a storage protein in seedlings of wheat, barley, and rye. When kneaded with water, this protein attaches in a strong matrix that makes up the structure of bread. For those with celiac disease, the body detects gluten and declares the sky is falling, causing damaging inflammation and gastrointestinal problems. Celiac disease affects around 1% of the population worldwide, though this number is increasing rapidly. There's a genetic component to celiac disease, and sufferers must have an immune mutation known as HLA-DQ2 or HLA-DQ8, though this isn't enough on its own to guarantee celiac. Studies of twins show that the underlying genetic predisposition needs an environmental component to become celiac disease. Beyond genetics, other risks include being female, Caucasian or white, and being exposed to gluten. Celiac used to be thought of as a disease in children, but we now know that it can develop at any age. Rates of celiac are increasing more rapidly than genetics would allow, indicating that environmental factors play an enormous role, though how this works is still up in the air. Symptoms of celiac may be felt both inside the gut and beyond. Gut symptoms include diarrhea or constipation, stomach pain, poor nutrient absorption, weight loss, and flatulence. Outside the gut, symptoms may include blisters on some parts of the body, arthritis, anemia, osteoporosis, neuropathy, or other neurological symptoms. Sufferers may experience only a few of these symptoms, and some people only have symptoms outside the gut. Because of this and the ubiquity of gluten in Western diets, scientists estimate that around 80% of people with celiac disease may be undiagnosed. Many of these symptoms fall within the zone of the small intestine because celiac disease affects the innermost lining of the gut. When we consume wheat or other gluten-containing foods, it is digested into component pieces by the stomach and intestines to become food for the body and give us energy. Unfortunately for people with celiac disease, parts of gluten are detected by the wrong crowd, the Chicken Littles of the guts. Those HLA-DQ2 and HLA-DQ8 haplotypes actually describe a specific protein on the outside of immune cells within the gut. This protein acts as a detector, which detects dangerous particles so the body can mount an immune response. For people with celiac, the DQ2 or DQ8 detectors mistake components of gluten for dangerous invaders and present them to CD4+ effector T cells. These are crucial white blood cells that coordinate the body's defenses. With celiac, CD4+ effector T cells activate other immune cells and start an inflammatory cascade where the immune cells swarm the area and, lacking a clear invader, damage our own cells. Up until now, the only treatment for celiac disease has been to completely eliminate gluten from the diet. Even with this step, many people continue to suffer symptoms due to inadvertent exposure or rare associated conditions. This also comes with the added cost and decreased taste of gluten-free diets, which my cousin would describe as lacking. Clinical trials are looking into new methods of dealing with celiac disease. One promising avenue is immune tolerance. This is the concept of boosting regulatory T cells, which lower the impact of CD4+ effector T cells and decrease inflammatory immune responses. Getting this to work inside the gut would be a game changer for people with celiac disease and might even allow them to eat gluten without experiencing symptoms. When it comes to the benefits a successful clinical research trial can have, the sky's the limit. Thanks for joining us on this week's episode of MedEvidence Articles. If you'd like to know more, all of our descriptions are linked in the podcast description below. You can also visit our website at medevidence.com. MedEvidence helps answer the question of who can you trust for medical information. The MedEvidence platform provides valuable information about many medical issues and the insights of evidence-based medicine. MedEvidence educates audiences through engaging and entertaining magazines, podcasts, videos, articles, and presentations. We strive to bring together diverse voices of top-level medical professionals, researchers, and experts to provide unique and engaging content that uncovers the truth behind the data. For more great content, including discussions by physicians and subject matter experts, check out the MedEvidence podcast. My name is Benton, and we'll see you next week.